Hello my dear, I welcome you all in this series of Score Booster. So first series already completed. That series is related to the fluid mechanics, that is part 1 and part 2. Now we have to discuss with the machine design. Okay, one second. Okay, so this is the series of machine design, and we know that machine design, the weightage in the gate is 4 to 5 marks. So this is enough. That means one session is enough for machine design. One session is enough. So we'll start the machine design score booster, and we in this score booster we already हमने एक बढ़िया सा क्वेश्चंस पूरे टॉपिक से एक दो क्वेश्चन बढ़िया क्वेश्चन कलेक्ट किया आपके लिए. I will try to solve, and also it is not only to solve. I am not only to solve, but also I will provide you the basics inside all the concept, all the questions related to basics concept related to all the questions, so that if there is something will change in the main gate examination, you can easily visualize. Yes. Okay. So let's start today's first problem. Let's start today's first problem. Before that, this is our content part. That subject is 4 to 5 marks. In this one, we have to discuss design against static and fluctuating load, welding and riveted joint, friction clutch and brake, rolling and sliding contact bearing, and design of spur gear. Design of spur gear we will discuss. Okay. Hi through. Now, this is the first question. Okay. So this is the simple questions, but this question is very good question. What is that? This is your bar, which is one end fix. This is overhanging type of bar. One end fix. Other end, this is L section. Other end we apply the load 4.5 kilonewton. Okay. So a bar of diameter 40 mm. This bar, uniform bar is there, and it is a 40 mm diameter, subjected to a following load. Subjected to a following load 4.5 kilonewton. And if the strength of this material, bar strength of this material, it is given, yield tensile strength it is given 280 megapascal. Find the factor of safety using failure theory. Which theory of failure? The theory of failure is your maximum distortion energy theory, MDET. MDET we have to discuss. Okay beta, I will give you a timer for 1 minute, and I want to that you can just try it, beta. You can just try. Okay. Everyone who are present here, just try it. I will give you solution. Done. Time up. So these are the questions. The figure it is given in the question. So what we have to do with here? See this one. There is a shaft. This end is fixed. So if you apply the load, first I identify which section is a critical section. If you apply the load, let's suppose there is point is A, there is point B. Let's suppose there is 4 point. There is circular, na? This shaft, the base is a circular. So you take a 4 point, top, bottoms, left and right. there is a 4 point, and we identify which point is your critical point, and the point which is critical, accordingly we have to design this bar according to the maximum distortion energy theory. So we first find the critical section, that means critical point. Here it is not a section, critical point. Let's suppose this is A, this is B, like that, bottom is C, and each side there is a D. So which point is your critical point? We identify like that. So my dear, let's suppose yes. So obviously there is a base. This is your base. Let's suppose we have to write the axis. So this is your axis, my dear. Let's suppose this is our axis. Let's suppose this is our z axis. This is our z axis. This is our z axis, and let's suppose this is our z axis, and from here this is our x axis. Let's suppose this is our x axis, which is parallel to this end, and this is your y axis. So there are two axes, x axis, y axis, and z axis. So let's suppose this is your z axis, this is your z axis, this is your z axis, x axis, y axis. This is the coordinate of this bar. Okay. Now this, let's suppose this is, it is 200. Let's suppose this is A, and this is B, 150. So these two are perpendicular. This one, and there is in same plane. This is your same plane, and both are perpendicular to each other. Now we have to apply a force here. So what is the action of this force? What is the reaction of this force? Applying force will try to twist this shaft. This is your lever arm. So this into this will try to twist this shaft, and also if you apply the direct load here, it will be binding. So in this shaft there is a twisting and binding, that means a combined loading system. There is a twisting. If you apply this load is applied, so this bar will twist, and if you apply this load directly, why? Because we know that if you shift this load on this surface, this point, so this load up and this load down, both are in equal magnitude, and here we have to shift this load. So one component of the one action of this load will provide the twisting effect, and other effect will provide the bending effect on this bar. So on this bar there is a combined type of loading, twisting loading, and also there is a binding loading, binding force, twisting, there is a twisting and there is a binding. That means torsional moment and binding moment both will produce in this bar. Okay. So okay, so let's suppose this is your surface. Yes or not? This is your surface, this one, fixed surface. Let's suppose this is your fixed surface. This is your fixed, yes or not? This is your fixed. On this one, this is your bar at this position. This is your bar. Okay, this is your bar, and this bar, on this bar, it will produce a clockwise twisting moment on this bar. On this bar, my dear, produce a twisting moment on this surface, which is, let's suppose, T is the twisting moment, and obviously my dear, this is our z axis, this is our z axis, this y axis, and this is your x axis. Yes or no? So this is on the base, z, y, and x. So there is a twisting moment on the base. If you apply this load, there is a twisting moment on the base. Now, and also this load, so there is this load will try to twist this bar, and also this load will try to shear. This also will, why? Because this is a perpendicular load. So there is a shearing effect. So in this one there is a shearing effect. This one there is a shearing effect, which is downward like that. It gives the shearing effect perpendicular to the base. So this is your V. Let's suppose shearing force V. V is your shear force, and this parallel to the given cross section. This is your parallel to the given cross section. Now, my dear, this is the load. This is a load acting on the base. First, due to this load will try to produce a direct shear stress. So this is your direct shear stress. This load will try to produce the direct shear stress. Yes, this is a beam. So this load is produced to direct shear stress, and this load also try to produce a twisting moment. So there are two type of loading condition is there in this one. Now this is our shaft, obviously. Yes, this is our shaft. This is our shaft. This is our shaft, my dear. This is our shaft. Yes. It is like that. Yes, it is like that. This is our this thing. Now, this is your base. At this point, this is your torsion moment in, let's suppose this is your anti-clockwise. So at this base, it will produce, at this base, it will produce anti-clockwise reaction, empty torsional moment at this point. And due to this force, there is a reaction upward. Let's suppose this is F, and this F is equal to nothing, it is your V. This length is L, B it is given, no problem. This is your B, and this length is your A. This is your B, and this length is your A. This end is A, this end is your B. Okay? Now, here the force is applied, that is your 4.5 kilonewton. Okay? And this is your Z direction, obviously. This is your Z direction. So in the Z direction, counterclockwise, yes, it is anti-clockwise, so it is a counterclockwise, torque will produce MT, and that is what, beta? Force F into A. F into A, yes or not? Force F into A. F into A. This is your counterclockwise will produce at the end, at this end. This is your reaction, so this is your action, okay, at this end. Now, so these are the torque. Now, on this beam, and this beam, there is a direct load will applied, which is your binding effect. So this is your, let's suppose, there is a shaft, here we have to write, there is a shaft, this end is fixed, this end is fixed. So here there is a direct load will applied on this shaft, there is a direct load will applied here. Yes or not? If you take this one, so F it is your given, and obviously this is your Z direction, this is your Z direction, Z direction, my dear. So this force will produce a binding moment like that. So here it is a reaction binding moment, it is in this direction. So this is your binding moment MB, this is your binding moment MB. So it will be tried to bend like that. It will try to bend like that. Okay, it will try to bend like that. So this will provide a action MB. So it will produce like that. So obviously upper part is your tensile nature, lower part it is your compressive nature. Okay. Now this is your y-axis. Obviously this is your y-axis, and perpendicular to this is your z-axis, x-axis. Okay, so these are the binding moment. These are the binding moment. These are the torsional shear stress. These are the binding moment. These are the torsional shear stress. Now, so at the top, if you draw the circular section, so at the top, this is your neutral axis. This is your neutral axis. So at the top there is a tension, and at the bottom there is a compression. And it is not a variable load. It is not a rotating or fluctuating. It is a static load. So always there is a on the top there is a tension, and bottom it is a compression. Bottom at it is a compression like that. So so the binding moment, see my dear, the binding moment, the axis of binding moment about which axis? Binding moment about z axis. This is on this one perpendicular to this direction is what? Z direction. So if you give the binding moment, the action of the binding moment, it is z direction. It is in z direction, and torsional moment it is x direction. So in this direction there is a direction of binding moment, and z direction there is a direction of torsional moment. Clear na? So binding moment about the z direction, about the x direction. Why? Because it will be downward. So it will be downward. That means it will be bend about this axis. It will be twist about z axis. So there are two directions. Along z direction there is a torsional moment, and along the x direction there is a bending moment. There is a bending moment. So again, if you draw like that, so these are surface. Let's suppose this is your fixed surface. We assume like that. This is your fixed surface. This is your fixed surface, and this fixed surface, this is your base. Okay, these are the axis. Why? Because we want that this is which point is the weakest point. So we have to draw finally. So this is your z axis, y axis, x axis. Okay, z axis, y axis, x axis. Okay, so in this direction torsional moment, in this direction binding moment. Clear na? And their y direction downward is a shear force. Very important, is a shear force. This direction there is a shear force V. Clear? This is your V, and this V is nothing is equal to F. Clear? At the base, what is the loading condition at the base? So these are the loading. These are the twisting moment, these are the binding moment, and these are the direct shear stress at the base. So see, what is this one? This shear force will produce a very low. This will in this geometry, the shear force does not affect much more. That means we have to write here one thing. Will produce shear load, this one shear load due to the shear due to produce shear load due to the bending. Shear will produce shear due to the bending effect, and the shear load due to the bending effect is always negligible, but its magnitude is 1 by 100 of maximum bending stress. So we can neglect. So it will neglect. So only we are bothering about the two loading condition. One is the twisting load and other is the bending load. Okay. So let's suppose, my dear, this is our section, fixed section. Okay. This is our fixed section. Let's suppose this is a fixed section, fixed one. And at the fixed one, let's suppose we have to draw this axis and this axis, let's suppose. So there is this axis. So this axis is what? X axis. This axis is what? Y axis. And perpendicular to this one, there is a Z axis. So we have to take the different element at the, we have to take, let's suppose this is one element we have to take here. We take another element here. We take another element here. We take another element here. So let's suppose we are taking 4 elements, and we identified which element undergone in a critical loading condition. Okay. Now, and obviously this is what? Twisting moment. So all the section, there is a torsional shear twisting moment. So there is a twisting moment is there. So there is a torsional, this is a torsion, no? So there must be a torsion shear stress in this direction. There must be a torsion stress in this direction equally. There must be a torsion stress in this direction equally. There must be a torsion stress in this direction. So this is the direction of torsional shear stress. This is the direction of torsional shear stress, tau. Okay, torsional shear stress. So this is your tau max. Tau max, all are same. Why? Because it is a periphery. At the periphery, shear stress is maximum. So all are same. All sections have a same value of torsional shear stress at a radius capital R is the maximum. Now, now my dear, on this element, let's suppose this element is, let's suppose A, B, C, and this element is, let's suppose D. This element is D. Now, what is the binding moment on each and every element? What is the binding moment? See, my dear, this is a neutral axis. So at the neutral axis, there is no bending stress. There is no bending stress. So in this one, there is no, at A point and B point, there is no any bending stress. Why? Because neutral axis. Why? Because at y is equal to 0. At a neutral axis, y is equal to 0. So there is no bending stress. But here will produce the bending moment. What is that, beta? If the shaft, if it is shaft is there, the shaft is trying to bend downward. The shaft is trying to bend downward. So upward it is a tension, and bottom it is a compression. So upward it is a tension. So upward it is a tensile nature. Upward it is in tensile nature. So it is in tensile nature. Upward it is in tensile nature, and bottom it is a compressive nature. Bottom it is a compressive nature. Yes. So this is magnitude is same. Sigma B max which is in tensile nature, sigma B minimum which is in compressive nature. This is also maximum, but we can say that it is not a minimum. This is also maximum, but in compressive nature. But it is in compressive nature. So my dear, see this thing. So here we have to write like that, ki sir, A and B, point A and B are neutral axis, lies on neutral axis. So bending stress is equal to 0, though there is a torsional shear stress, and C and D there is a maximum binding stress. There is a C and D there is a maximum binding stress, and A and B their binding stress is 0. So what is the maximum binding stress, my dear? What is the maximum binding stress then? We know that sigma B max, we know that 32 sum formula, binding moment divided by pi dq. Now my dear, so maximum binding moment, sigma B max, binding stress 32. What is the binding moment? Binding moment will produce due to this effect. This is the load, beta. Load, so load will act here. So what is the length? 0.15. 0.15. 150. For the torsion, we have to take this length. Why? Because it is torse, and for the binding, we will take this length. So binding 32 into MB. MB is your force. Force is how much? 4.5. And 4.5 is what? Kilonewton. So we'll convert, it is in Newton, 10 to the power 3. Into this length. Length is what? 150. Divided by pi. Diameter is what? Diameter they are asking about 40. Diameter is how much? This diameter is how much? 40. Diameter is 40. So 40 the power q. If you solve this binding stress, the value is, please tell me, 107.3 megapascal. So this is a binding stress maximum. This is a maximum binding stress. Now, what is the maximum shear stress? Please write down 16 tau T pi dq. 16 T pi dq. 16 T, instead of T there is a MT. We can write also MT also, no problem. Every other different book have a different notation. So this is MT. Now 60. What is torsional moment? Torsional moment is 150 into 200. So this is 150. That means 150 into 4.5. So this is 150 into 4.5 cross 10 to the power 3 divided by pi 40 per q. So if you solve this one, it will get 71.6 megapascal. Clear? Megapascal. So my dear, the section B and D have a combined effect, and the effect is this sigma. So there is a shear stress, binding stress. This is a perpendicular binding stress. This is shear stress is cross section parallel. So these are the parallel to the cross section, parallel to the cross section, parallel to the cross section, parallel to the cross section. Okay. So these are the binding stress, and this binding stress and shear stress will act at a point D and B. So D and B point is a critical point. So we can take any of this point we have to design for the safe according to maximum distortion energy theory. So automatically point A and C will safe. Why? Because point A and C will still there is a less load bearing capacity, less load capacity. So it will be safe already. But here the more load will act at a point D and B. So we can safe. We are design the shaft like that. It will safe at a point D and B. Okay. So critical location is what? critical location is what, beta? Critical location is two stress acting. Critical location is what? D and B. D and B, and here two stress will act. Bending stress and torsion stress. Yes or no? Two stress will act. Bending stress and torsion stress. Now, if you take the state of element, state of stresses at point D and B. So at a point D, there is a shear stress and tensile compressive 1D. This is 1D, and at point A only the shear stress. So if you take, let's suppose we have to take the element, that means element at this point and this point. Obviously, this is, we are not designing according to A point, we are designing D, but by interest, what is the state of stress at point A and D? Let's suppose. So state of stress at a point A and D, A and D. So let's suppose this is state of stress A. This is your A, state of stress A. This is state of stress B. Two state of stresses is there, and obviously this is x-axis, this is axis. Yes, this is also axis. This is also axis. Okay. Now here let's suppose this is a state of stress A and this state of stress C. Let's suppose A and C. A and C. No, A and D. A and C have the same nature. A and D. A and D. So my dear, A and D, here at point A, there is no any normal stress. There is no any normal stress. So in this condition, the normal stress is 0 at point A. Okay. At point A, there is no any normal stress, only the shear stress is there. So at point A, only the shear stress, pure shear, only pure shear tau. But at a point D, there is a tensile stresses, and at a point B there is a compressive stresses. Let's suppose we have to take at a point one more state of stress. So let's suppose this is C, this is D and this is B. So D and this is, let's suppose, B. So at a D there is a shear stress, at a D there is a shear stress. So there is a shear stress, there is a shear stress, there is a shear stress, and also there is a tensile stresses, but that tensile stresses is uniaxial, tensile stresses. So tensile stresses, also there is a tensile stresses at point D. At point D there is a tensile stresses. So at point D, so this is, and here sigma y is equal to sigma, two direction, let's suppose there are two direction. So one direction, let's suppose this is sigma x is there. There is a sigma x and sigma y is equal to 0. Sigma y is equal to 0. You have to take the sigma y is equal to 0, 1D. And here there is a compressive nature. Here there is a compressive nature. Sigma b is equal to minus of sigma b max. Or here again there is a shear stress. So these are the state of stresses. These both are same state of stresses. So here what is tau here? Tau, it is your 71 0.6 megapascal. And what is the shear stress, binding stress? That is your 107.3 megapascal. Yes or not? We already calculate this thing. Now, so we have to design according to the maximum distortion energy theory. So what is the average? Average shear stress, sigma x plus sigma y by 2, or you can directly find according to MDET, that is one relation also. So there are both method you can find, both method. So there is one relation also for that. If there is a two dimensional, we can also find for the normal method, and we can also find for the applying the formula. We'll discuss this thing. So sigma average is what? Sigma, this one 107.3 plus 0, y it is 0 divided by 2. So this is how much? 53.6 megapascal. What is tau max? Tau max is equal to plus minus root under only one stress, sigma x by 2 whole square plus tau xy whole square. So if you put this value in this one, so this is your plus minus 89.5 megapascal. Now, so sigma 1 is what? So measure principal stress, sigma average we know that, plus tau max. This is your radius. If you put this value, it is your 143 megapascal. Okay, and here sigma 1. And what is the minimum? And here let's suppose sigma 2 is equal to 0, sigma 3 is minimum, and that is your sigma average plus tau max. And here one tau max is minimum. So sigma average and put minus, second one is minus. So if it is will be minus 35.9 megapascal. So this is your maximum and this is your minimum. So by MDET, maximum distortion energy theory, we know that SYT by N is equal to half sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square. We know this thing. SYT, it is given 280 divided by N, and if you rearrange this thing, just we have to write 1 by 2 within bracket 143 square, sigma 2 is 0, plus 35.9 square plus minus 39.5 minus of sigma 1 143 ka whole square. So if we rearrange this thing, here N is equal to 280 by 164, and that is 1.7. This is your factor of safety, 1.7. That's it. 1.7. So simply we identify the critical section and find the, according to the elementary equation of the SOM, we have to find the maximum binding stress, that means binding stress and torsional shear stress. Now apply, and then we find the principal, that means if you apply this maximum distortion, there is a principal stress, sigma 1, sigma 2, sigma 3. So here maximum this one, minimum of this one, and in between this is 0. So we have to take like that, sigma 1, sigma 2, sigma 3, and then we have to find the shear stress. Clear? Clear? Na? Done? Okay. Now, before going to the next problem, I have one announcement. What is that? See, there is a test series plus. This is the plus. It is not only test series. More than that of test series. This is not only for test series. That means you are doing the test. No, test series plus. What is the meaning of plus? We have access of these things. What is that? 130 plus online test is there, and along with that 33 year of GATE PYQ. One is technical and 33 GATE PYQ separate mathematics and general aptitude. There are two books. One is your technical book and other one is a mathematics book. Also, we have also, if you access this one, if you join this test series plus, you have also benefited by doubt solving portal. There is a doubt solving portal you can access and ask to anything with the faculty, and online revision and GATE score booster. You got the online revision and GATE score booster also. Post GATE guidance counseling also, and also there, if you have a opportunity to qualify the PSUs, we conduct the interview also, so we can join the also interview. And if you know that, so if you access, you get a 10-20% instant. Let's suppose there is this is your technical book. See my dear, this is your technical book. This is your technical book. So one book is there. This is electronics and communication, like computer science, like there is also mechanical, and there is another book, engineering and general aptitude, like that. Okay. Now, again, if you join the regular course, live online program, if you join live online program, so what is the benefits? What मतलब आप benefit क्या होगा आपको मिलेगा प्रोग्राम फीचर्स में 800 plus hour live classes with live interaction, and also you got theory book, exercise book. In this exercise book, beta, theory book and exercise book. In this theory book and exercise book. So in this exercise book, 4,000 plus question is there, and all questions are categorized by level 1, level 2, level 3, like that. Okay. And they cover all the things like a GATE to all type of competitive examination, level 1, level 2, level 3. It is like that. And the number of questions approximately 4,000 plus, and also it is not 34. Also we have 33 year of GATE question bank with a video solution. This is very important, with a video solution. That means maximum question में आपको QR स्कैन कोड रहेंगे. आपको अगर कोई प्रॉब्लम में दिक्कत हो रहा है, लेट्स सपोज यू आर सॉल्विंग एनीथिंग, any question, and you find a better, you don't understand, you are not feel better to understand, then just scan the QR code, the video you have, and in front of you the video is playing. वीडियो आपका प्ले होने लगेगा और आप आराम से उसको देख पाएंगे. उसके बाद आपको 12 1-to-1 mentorships, दैट मीन्स 12 पर्सनलाइज 1-to-1 mentorship मिलेगा आपको. मतलब डायरेक्टली आप टीचर से बात कर सकते हैं, समझ सकते हैं, आप अपना बेसिक प्रॉब्लम बता के आप उसको सॉल्व कर सकते हैं. नेक्स्ट 133 ऑनलाइन टेस्ट विथ ए वीडियो सॉल्यूशन ऑफ ए मॉक टेस्ट एंड मेनी मोर. दैट मीन्स व्हाट इज आप अगर 133 ऑनलाइन टेस्ट देते हैं तो उसमें आपको उसमें आपको वीडियो सॉल्यूशन भी मिलेगा, उस क्वेश्चंस के सॉल्यूशन भी मिलेंगे, वीडियो सॉल्यूशन भी. इफ यू वांट टू मोर डिटेल, just click this link, and also you can call on this number, so they can directly reply you for the better understanding. Okay. Okay. Next. Yes. Next is this problem. Please read this question, beta. Please read this question. And mind it, this question is very good question. I am telling you this question. Now the question is very good question. What is that? A thin spherical vessels of diameter 200 mm and thickness 1 mm is subjected to an internal pressure which is varying from 4 to 8 megapascal. It is varying. Assume that the yield, ultimate and endurance strength of the material it is given. Yield strength, endurance strength. In the question, if it is endurance strength it is given, now you can assume this, that is our corrected endurance strength. So endurance strength of the material it is given, and ultimate is given. Factor of safety with respect to fatigue failure. with respect to the fatigue failure. That means we are doing two tests. One is the fatigue failure. So if you're doing the fatigue failure test, in that one the factor of safety is 1.3 N. What is N? N is the factor of safety with respect to static failure. So there are two types of fatigue failure theory, factor of safety it is given. 1.3 N, it is your fatigue failure theory, factor of safety due to the fatigue failure theory, and N, it is the factor of safety due to the static failure theory. So value of N, we have to find the value of N according to modified Goodman relation. My dear, in many books these problems are, that means in the problem, ये आपके problem में 90% Goodman relation से solve किया गया. That is wrong. Here it is a modified Goodman line. How to find the modified Goodman line? First find the factor of safety according to the Goodman, then find the factor of safety according to the Langer line, and which factor of safety is minimum, that is your correct answer. That is your modified Goodman line. So modified Goodman criteria, it is a Goodman, find the factor of safety according to Goodman, and find the factor of safety according to Langer, and the area of between the Goodman and Langer line below the area, that is your modified Goodman line. So we have to take two types of factor of safety. First one is the Langer line of factor of safety, second one is the Goodman, and then we have to select the minimum one is there. Okay. So this is the value 1.5, 1.23, 1.43, 1.39. But I will give you 1 minute time. Please start and please try to solve. Time is up. Okay, now we'll start this problem. So a thin spherical vessel is there, inner diameter it is given, thickness is given. Okay, no problem at all. So given okay, ये extra page है, इसको delete करते हैं. Okay, so what is given? Given is what, beta? Given inner diameter, inner dia, let's suppose D, it is given 200 mm. Okay, thickness of the material, it is given 1 mm. Okay, maximum pressure, yes, it is given, varying subjected to an internal pressure varying from 400 to 800 megapascal. The pressure is varying inside the pressure vessels. So P maximum, it is your 8 megapascal. Minimum pressure, it is your 4 megapascal. Okay, ultimate tensile strength, it is given 800 megapascal. Yield tensile strength, it is given 600 megapascal. Corrected endurance limit, it is given 400 megapascal. Okay, take N2 is your factor of safety. Factor of safety with respect to fatigue failure. Fatigue failure. Let's suppose, and this is given how much? 1.3 N. And N1, let's suppose, is your factor of safety with respect to static failure. And it is given N. Yes or not? This is given. Now, here KT is your theoretical stress concentration factor. Theoretical stress concentration factor, which is account for the variable load KT. KT is it is account for the theoretical stress, account for the static loading. This is KT theoretical stress concentration factor account for the static loading, and KF is the fatigue stress concentration factor. Okay. So beta, there is one thing, if you apply the question it is given, fluid mechanics गुरुजी नहीं, excellent, no, solid mechanics, no, fluid mechanics नहीं, this is a machine design. Okay, thank you. Now, if you apply in this question, it is given that modified Goodman. So my dear, always remember, with respect to a modified Goodman relation, we have to find the factor of safety by using two equations. One is the Goodman equation, other one is the Langer equation. Okay, so always remember this one. According to the Goodman, modified Goodman, we have find the first apply Goodman relation. First apply Goodman relation and find the factor of safety. Okay, then we have applied the Langer's equation. Then we have to find the factor of safety, and which factor of safety is less, that is our answer. That means minimum of these two, always taking. So we are taking minimum of these two. These two is our answer. So it is a simple. Now we have to apply the actual Goodman. Okay, so actual Goodman equation. In actual Goodman equation, what is that? This is very important. Actual Goodman, see, mean stress, write down, mean stress divided by strength. Which strength? Ultimate strength. Divided by factor of safety. So this is a mean. This is a static condition. So it is your N1. What is that? Static condition N1. This is okay. Plus sigma V divided by endurance divided by N2. This is a variable less than equal to 1. Now my dear, here don't forget, multiply the concentration factor, theoretical stress concentration factor, fatigue strength. So fatigue here Kf, here Kt. Here it is not given, so we have to take this is 1 and also this is 1. In the question there is no any mention this value, so we are taking 1. Okay, so these are the actual Goodman relation. Now there is actual Langer's line, and Langer's line is connection between the yield strength beta. Connection between the yield strength stress line. So mean stress divided by sigma yt divided by n1 plus sigma v divided by sigma yt divided by n1 less than equal to 1. Here we have to write Kf. Okay, here we have to write Kf. So these are the actual Langer line. So first we have to find the factor of safety according to this one, then find the factor of safety according to this one. Okay. What is this, my dear? This is what? This is your permissible shear stress. Permissible shear stress is what? Maximum stress divided by factor of safety. Yeah, failure stress divided by factor of safety. This is your permissible shear stress. Permissible stress. So permissible stress for the brittle material under the static condition. So these are the permissible stress. That means you can write that this is your sigma permissible shear stress for brittle material. Why? Because this is ultimate for brittle material under static condition. Static condition. And what is this? This is also permissible shear stress for fluctuating load, yeah, varying load, for fluctuating kind of load. Fluctuating kind of loading. This is a fluctuating kind of loading. Okay. Now, there is an important thing here. Note down here, beta. What the formula it is given in the textbook, in the solution part of anywhere there is a solution, that we apply the only Goodman's, and that one with a modified Goodman. Yeah, this is your actual Goodman line, and this formula what we have to write like that. 1 second. This one here. Take a note. What is that? If both factor of safety is same, that means only one factor of safety it is given, then the value it is your 1 by n. That means modified Goodman, let's suppose this is 1 and this is 2. So 1 it is written as Kt sigma m divided by sigma ut plus Kf sigma v divided by sigma e less than equal to 1 by n. This is a modified Goodman. Second, Langer line. This is a Goodman. Langer line. Again Langer line. Here sigma m divided by sigma yt plus sigma kf sigma v divided by sigma yt and less than equal to 1 by n. So these are the modified, these are the when this equation is suitable, when there is a factor of safety is same. So this we cannot use this formula here directly. Why? Because their factor of safety both are differ. For static condition their factor of safety is n, and for the dynamic condition the factor of safety is equal to 1.3n. So we cannot use directly this value. This is a mistake here. Okay, this is only when there is a same factor of safety it is given. Please note down. Now here we have to find sigma m and sigma v. So for the thin pressure vessels, what is the mean pressure, maximum pressure plus minimum pressure divided by 2. If you put this value, this is your 6 megapascal. What is the variable pressure? Just negative. P max minus P minimum divided by 2. Put this value, this is your 2 megapascal. And 2 megapascal is nothing. P mean divided by 3. Yes or no? 6 hai na? So this is P mean by 3. Now, here we have to design the pressure vessel according to hoop stress. Because hoop stress is a critical stress in this case. So hoop stress mean, we know that from formula, mean PD upon 4 T. We know this thing according to SOM equation. So from here, if you find P mean, 6 into dia, it is your 200 divided by 4 T, it is equal to 1. So this value, it is your 300 megapascal. Similarly divided by 3, 100 megapascal. So sigma hoop variable, sigma hoop mean by 3, that means 100 megapascal. Why? Because this is your P mean by 3. Now, from equation first, from equation, this, let's suppose this is equation number first and this is equation number second. From equation first, from first, what is the first equation? Sigma m divided by S ut divided by n1. Yeah, you can write n SUT. Okay, no problem. Here n1, and n1 is what? Here it is a n1 and here it is a n2. So here n1 plus sigma v induction strength divided by n2. Here we have to multiply KT. Here we will multiply KF. Less than equal to 1. Okay. Put this value. Nothing it is given. KT is 1. Sigma mean it is your 300. SUT it is given 800 divided by N1 plus KF, it is nothing, 1. Sigma V is 100. SE it is given 400 and N2 it is given 1.3 N, less than equal to 1. So if you find N value here N is equal to N. Here we have to put N. Okay, N1 is equal to N. N1 is equal to C. N1 is equal to N. So here, if you find this value it is N is equal to less than equal to 1.428. This is the first. Okay. Now we have to take the second equation. Second equation, my dear, and that second equation is what? Langer equation. So from second Langer equation, sigma m by sigma yt divided by n1 plus kf sigma v divided by sigma v divided by yt divided by n1, both here this less than equal to 1. So sigma m it is your 300, yt it is your 600 divided by n plus Kf is equal to 1, sigma v it is your 100, Syt it is your 600 divided by n less than equal to 1. Now, so from here if you find the Langer line, the factor of safety n is equal to 1.5 less than equal to 1.5. See my dear, all the option are it is given. See 1.5, it is also given 1.5. It is also given 1.428, 1.428 and 428. So which option is correct? Minimum. Now my dear, if you find this equation, if you find this equation, if you find the answer of this question according to only Goodman relation, according to Goodman relation, the answer is wrong and it is 1.5 answer it is given. That is wrong. So that's why this question is important. Why? Because there is 2 factor of safety given it is. So, and according to modified Goodman, first we have to find the Goodman and then second one find the Langer equation. With these 2 equation, we have to find the factor of safety of 2 factor of safety and we take always of minimum of this 2 factor of safety. So, according to the Langer line, according to the Langer line, it is your 4.28 and according to Langer line, it is your 1.5 and according to the Goodman's 1.42. So, which one is correct? 1.428, that means approximately 1.43. 1.43 is a correct option. 1.43 is your correct option. Clear? Clear na? This thing is clear? So this is the questions. Now next question is that, next question is this one. Please read this question carefully also. What is that? A circular bar of 4 meter length, there is a circular bar of 4 meter length is clamped at ends, which is clamped at ends at a temperature of 30 degrees centigrade. The bar subjected to a temperature 30 degrees centigrade. A twisting couple, and along with that there is a twisting couple 1000 Newton meter is applied at a distance from 1 meter from the left support. A twisting moment will apply at a distance 1 meter from the left support. Determine the bar, determine the dia. What should we say? Determine the dia. This is dia. Determine the dia of the bar. Determine the dia of the bar by using, see, maximum distortion energy theory. Again MDET. Maximum distortion energy theory in mm. So this is your NAT type question. This is your NAT type question. I will give you again 1 minute. Just try to solve. Time up. Okay, done. So what is that beta? In this question, what is there? There is a circular bar, and which is this is, let's suppose this was circular bar. Okay, 1 second beta, I am going. So this is your circular bar, let's suppose, okay, and this bar both end is clamped. That means both end is fixed. Number first. Number second, in the bar there are two things. First one is the temperature variation. In the bar there is a temperature will vary. What is that? See, 30 degree. When it is cooled to a temperature minus 70 degree, that means initially it is 30 degree and now the bar will try to cool up to minus 70 degree. That means the bar temperature will reduce. So my dear, when the bar of the bar, this member, the temperature will reduce and both side is clamped, what happened? The bar try to contract. Bar try to contract. Why? Because temperature is reducing. Bar try to contract. Now, but the end is clamped. So end doesn't want to go the bar. End doesn't want to contract the bar. So the at end there is a tensile, axially tensile force will act due to decrease in temperature. This concept is clear. Now, so and also we are applying the torsional moment at 100, torsional moment of 1000 meter applied a distance 1 meter from the left support. That means total is 3 meter bar. Total is 3 meter bar. How much it is given? 1 meter from the left support. Okay, it is not given. So total it is given 4 meter. 4 meter. The bar length it is, yes, it is given. Bar length is 4 meter. So this bar length, on this bar length, from the left support at 1 meter, we applying the twisting moment. So there is a torsional effect. So there is a torsional moment. There is a torsional moment. So there is a torsional shear stress will develop due to this twisting, and one shear stress will develop due to the tensile in nature. Why? Because there is a axial stress will develop. Why? Because this bar is there and now you have to reduce this temperature. The bar try to contract, but the clamp is very rigid. So they doesn't want to contract the bar. So at the fixed end there is a tensile, axial tensile load will act. So it is again combined loading. Clear? Now we will start this problem. So what is given? And here it is given, beta. It is given. In the question it is given, beta. Otherwise we cannot able to solve. Thermal expansion coefficient it is given alpha 12 cross 10 to the power minus 6 per degree centigrade. Young's modulus of elasticity of the bar it is given 200 gigapascal. Yield shear strength it is given 300 megapascal and factor of safety it is 1.5. Factor of safety it is 1.5 it is given. So we have to find dia of shaft, dia of bar. Clear na? Clear? Okay, let's start. For that one, there are two support. This is your bar. This is your bar, my dear. Okay, will not write like this is your bar. Okay, this is your bar, and both end is fixed. This is your center line of the bar. Both end fix. This end fix, and this end also fix. Both end is fixed. Now, let's suppose this is A, and this is your, let's suppose C. This total length it is given 4. This total length it is given 4. This total length is given 4, and from left 1 meter, from left 1 meter to the left 1 meter, we are applying a torsional moment. we are applying a torsional moment. So let's suppose this is point B, and at B, let's suppose this is point B, and we are applying a torsional moment. We are applying a torsional moment T, that is your 1000 Newton meter. We are applying at a point B, we are applying a torsional moment at 1000. Now, this is your dia. We have to find this dia of the shaft. Now, my dear, this shaft, the temperature delta T, change in temperature is how much? 100 degrees centigrade. Yes. Initially it is 30, finally it is minus 70. So how much change in temperature? 100 degrees centigrade. So 100 degrees centigrade is cooled down. This much of temperature will reduce. This much temperature will reduce. So, this is your 1 meter. So this is your 3 meter. Now, we are separate with the load diagram, two effect. The load diagram will have a two effect. First effect is due to my dear, first effect is due to the torsional moment. First effect is due to the torsional moment, and second effect is due to the change in temperature. Second effect is due to the change in temperature. Second effect is due to the change in temperature. Okay. So, let's suppose this is your member. Okay. Now, at this point B, this is point B, this is A, and this is C. And at point B, we are applying, let's suppose clockwise or anti-clockwise, let's suppose we are applying a clockwise moment. Okay. So we have a direction. Let's suppose we are applying a clockwise. Why? Because moment is not given. So we have to write take clockwise torsional moment. Torsional moment. We are taking clockwise. So clockwise, it will give in this direction of reaction. So it will give this direction of reaction. From point B, it is in this direction. Double arrow, obviously. Double arrow. Why? Because it is torque. So in this direction, this is your torque. In this direction, here applied torque. So due to this applied torque, here at a fixed end, it will be reactive torque. So the reactive torque, it is in this direction. At this point, and at this point, it is in this direction. This is a reactive torque at fixed end. So what is this reactive? So there is a TA and there is a TC. Okay, reactive torque, balance. This in balance, this in, this is in balance. So we have to balance. This is towards A, so they are towards A. There is towards in this side there is away from B, so away from C. So that this is balance. Okay. What is TA here, beta? This is your TA torque. What is this TA? This torsional moment. How to calculate? 1000 into opposite distance 3 divided by total distance 4. These are the method. So this is your 750 Newton. This is a shortcut method. This is a shortcut method. When this method is applicable, when the torque is constant torque is applied. So what is the reaction of torque? 1000 into opposite length divided by total length. We know this thing already in the sum. What is here? So if it is your, this is how much? 1000. So this is your 1000, this is your 750. So in this direction there is a 250. This is your 250 Newton meter. Now due to the temperature effect. Now due to the temperature effect, my dear. Now due to the temperature effect. So this is your bar. Okay. This is a point of B. This is point of A. This is point C. Now my dear, due to the temperature effect, if you decrease the temperature, in this one beta, we have to decrease the temperature. That means this bar, temperature will decrease. So temperature will decrease, this bar try to contract, but this rigid support doesn't allow to contract that one. So at a rigid support, the force of reaction, it is your tensile nature. It is in tensile nature. So at this point, it is in this direction, and at this point, it is in this direction. So here, let's suppose this is your RA and this is your RC. Both same magnitude. This is your R and this is also R. Okay, this is your reaction. Done. Now, what is R? So, how much reduced temperature? Delta T. Delta T is the reduced temperature. So, how to calculate this reaction R, force R due to the temperature difference? Alpha del T into E, Young's modulus, into A, area cross section. This is the thermal load due to thermal load. That means due to temperature change, what is the load will applied? How much this temperature is responsible to apply this load, and this load is your axial load, beta. Okay, this is your axial. This is your axial direction. Okay, so if you find first, so what is the maximum torsion? So this is the critical section. These two are same. This section. So this at this section reaction is same due to thermal, but due to the torsion at this point the torsional moment is more. So A point is your critical section. So A withstand A withstand maximum load. So section A will be a critical section. So section A will be a critical section. Okay. So what is the maximum torque? 750 Newton meter. No. So this is maximum torque. So from this maximum torque, what is the torsional shear stress? Tau. 16 T divided by pi dq. We know that 16 T 750 divided by pi dq. So if you rearrange, this is your 3819718.634 divided by d power q megapascal. This is your megapascal. Okay. Now, what is the, so load upon area, this reaction upon area is the thermal stress. So what is the thermal stress? This thermal stress is nothing, this is your axial stress, and this axial stress is nothing, it is in x direction. Let's suppose this is your x direction. So what is this? Alpha del T into E only. Yes or not? Alpha del T into E. Why? Because divided by A. So this is your stress. Put the value of alpha 12 cross 10 to the power minus 6. Yes. 12 cross 10 to the power minus 6 into delta T 100 Young's modulus 200 cross 10 to the power 3 megapascal. So this is your 240 megapascal. It is in tensile nature. It is in tensile nature, my dear. So there are two stresses. One is the torsional shear stress, other one is the axial stress. So if there is a no first question, beta, in this first question we can also solve like that. In the first question, there is only two stresses is there. One is your shear stress, other one is your normal stress. That means shear stress and other one is the axial stress. Yani one stress is there, only one stress is there. So in this sense, we have to use direct formula of MDET. We already will discuss, this thing is already discussed in the main classes. So according to MDET, we know this thing. According to MDET, we know this thing, beta. Already we have to discuss in the class. Sigma T permissible greater than equal to square root of sigma x square plus 4 tau xy. My dear, this equation is useful when there is no any normal stresses is given. That means normal stress develop in the, that means the stresses will develop in one direction. When it is applicable, when the normal stress, will develop in one direction only. So in the previous first question, we can also apply this formula. So my dear, here this is permissible, the failure strength SYT divided by N is greater than equal to, this is your thermal, sigma thermal square plus 4 tau torsion maximum square, this is square. Okay. Now, and my dear, we know that here shear strength value it is given. In this question, see my dear, in this question, what is the, it is given 4 meter, itna left. Yes, shear strength it is given, yield shear strength. So according to MDET, according to it, what is the yield tensile strength, the relation between yield tensile strength and yield shear strength? So yield shear strength, yield tensile strength by root 3. Yes. This we know that according to MDET, yield shear strength, yield tensile strength divided by root 3. So my dear, here yield tensile strength is root 3 SYS. And SYS is given. So put here, instead of SYT, we have to put here root 3 SYS divided by factor of safety is greater than equal to thermal stress square plus 4 tau. This is obviously max square. So from here, put all this value. If you put SYS, it is given root 3 thermal stress tau. So here, if you find factor of safety, the factor of safety is equal to 29.808, approximately 30. You can write approximately 30, 29.808. This is your factor of safety of this equation. Clear? So this question is also important question, my dear. This is also important. Why? Because in this case the concept is thermal stasis is given. So combined concept it is given. In the gate sometime they will ask with respect to a combined effect. So there is this thing, if you know, then you can solve this formula by according to MDET criteria. This is the maximal distortion energy criteria, yield shear strength divided by yield tensile strength divided by √2, and according to MPST, maximum principal shear stress theory, yield shear strength is equal to SYT divided by 2. That means SYS is equal to 0.5 of SYT. Clear? This thing is clear. Okay. Now the next problem. Yes, please try to solve this problem. This is also good problem. A single plate clutch consists of one pair of frictional contact surface. A single plate clutch consists of one pair of frictional contact surface. One pair is there. Because of space limitations, the outer diameter of the plate is fixed as D. That means the clutch have an inner diameter and outer diameter. Outer diameter is fixed due to the space constraint. The permissible intensity of the pressure is P, and the coefficient of friction between the plate is mu. Okay, this is the coefficient of friction. Assuming uniform wear theory, that means P into R is equal to constant. What is uniform wear theory? P into R is equal to constant. This is a uniform wear theory. The inner diameter and outer diameter ratio for which the torque transmitting, this is the given condition, capacity of the clutch is maximum. That means for the maximum torque transmission by the clutch, according to the uniform wear theory, what is the D by D ratio? What is the smallest by capital dia ratio? So again I will give you 1 minute, please think, and then we'll solve this problem. Time up. Okay, we'll try to solve this problem. So as we know that during the clutch there is a friction lining and there is a friction between these two plates, and this friction will provide a frictional torque, and this torque, frictional torque, so due to this frictional torque, clutch will be clutch will be operate due to this friction force. So I will give some funda. No need to remember any formula, I am telling you. So this is a fundamental concept, my dear. This is a fundamental concept here. I will give you a fundamental, so that don't why this is why I am giving this one, Why? Because this is mandatory. Why? Because uniform wear theory, this is the torque. Uniform wear theory, this is the load. Uniform pressure theory, this is the torque. Uniform wear theory, this is the load. Don't write like that. Simple 2 step. So my dear, as we know that, this is our clutch. Visible. Okay, 1 second. I will just delete it and just write black. Okay. So this is our clutch. It is visible. Okay. Let's suppose this is outer diameter. This is outer diameter, my dear. Now, so this is outer diameter, and there is an inner diameter also. So here, let's suppose this is your inner diameter. Let's suppose this is inner diameter of the clutch. This is inner diameter. Now, and this is your friction lining, and the frictional torque will vary. Why? Because the area more and more, it will be varying area from the center to the periphery. So frictional torque will vary. So if you calculate the total frictional force, frictional torque or frictional force, we have to take an elemental ring. So there is an elemental ring. There is an elemental ring, my dear. Let's suppose this is our elemental ring. This is our elemental ring. This is our elemental ring, let's suppose. Okay. Let's suppose this is our elemental ring. This is our elemental ring, and this is your elemental ring, and this ring, let's suppose this is your radius Ri, this is your Ro, this is the distance R, any distance R we are selecting a friction lining, and this is your dr. We have to calculate what is the torque on this elemental ring. Then after that we have to integrate from Ri to Ro, and then we have to find the total torque. So what is the torque on this ring? What is the torque on this ring? On this ring. So first, what is the area of this ring? dA. What is the area? The area is your 2 pi r dr. This is the elemental area of the ring. And what is the axial force? That means if there is a 2 clutch, so 1 clutch and there is another clutch, to apply the to start the performance of the clutch, we apply the axial force. So what is its axial force? DFA force, axial force. So this axial force is the applied pressure at this section. At this section, applied pressure P into dA. P into dA. What is the applied force then? What is the applied force then, beta? What is the applied force? So this is applied, this is what? Applied force. Applied applied force, and this is your axial direction, axial force. axial force. Now, if you apply this force, there is a rubbing will takes place between two clutch, so there must be a frictional force. So, what is the frictional force? This applied force is a perpendicular to this clutch. This is your clutch and you are applying this force, and this force is a perpendicular to the clutch. So, what is the friction? This normal force into the coefficient of friction. So, mu into dFA. Mu into dFA. So, what is the applied torque on this ring? dt, frictional torque, is equal to dF into distance r. That's it. Straightforward. Nothing to remember. Straightforward. Okay. So, torque transmitted by each pair T, you can integrate. Now, dF, mu into dA, dA into P into dA, and P into dA 2 pi r dr. So, mu 2 pi r dr into P into r. Yes or not? Now, so we have to take common, mu common, 2 pi common, P into r common. Why PR into common? Why? Because uniform wear. Into r dr, Ri to Ro. Yes or not? Why this will outside? Why? Because uniform wear. We'll write here. Uniform wear. So, this torque T is equal to 2 pi mu PR integration you have to remove. Now, this is your Ro square minus Ri square by 2. So, this is your 2 pi mu PR, 2 to cancel कर दो, pi mu PR R naught square minus Ri square. This is torque transmitted by each pair. Single pair is there, so we are not multiplying n. If there is a 2 pair, we have multiplied 2. If there is 3 pair, multiply with 3. Clear na? So, this is our torque. Now, my dear, here we have to take some arrangement. What is that? Now, see, what is that, my dear? Here, it is given outer dia is fixed. That means D is equal to 2 into R naught is fixed. So, we have to take, so what is that? P maximum when R minimum, P minimum when R maximum is equal to constant uniform wear. So, my dear, outer dia fixed, we take Ro outside. So, here we have to write T is equal to pi mu P Ro cube into 1 minus Ri square by RO square. Yes or not? Here we have to take, here by default we are taking P minimum and RO. P minimum and RO, let's suppose. So we have to write like that. Now my dear, mu constant, pi constant, mu constant, P into R the power Q. This is constant, so only variable is Ri. Only variable is Ri. So we have to write like that. See, RQ. Okay, one second. So R, okay. So here Ri, one second beta, RO will take common. So this RI, RO, one second beta. So we have to write like that. See, there is one thing, R by Ri by RO you take X. You can take X. And if this is your, see, one thing. Now my dear, which value you have to take here? Which value? If you take any of these two value, if you take RO, so that is RO correct. No problem at all. If you take Ri, here if you take Ri, so P max, we always design the maximum. Why? Because beta, we want the maximum torque transmitted. So for the maximum torque transmitted, this P is max. This P is max. So for maximum torque transmitted, this maximum when P is max. So when P is max, R is minimum. So here you have to write like that, mu P into P, so R minimum Ri, here we took RO common, RO square, so 1 minus Ri square by RO square. Now my dear, see, what is, let's suppose take Ri by RO is equal to X. So here Ri is what? X into RO. So X into RO, Ri. So X into RO pe power Q. So torque T is equal to pi mu P into X RO cube into X into 1 minus X square. Yes or not? X into 1 minus X square. Why? Because torque transmitted is maximum, so P is maximum. So if the P is maximum, R is minimum. And here we have to put this R value back here. So this is X into RO pe power Q. So this is like that. Now my dear, so see, this is constant, this is constant, this is constant, this is constant. So T is the function of this quantity, X. So for maximum torque transmitting capacity is what? D by, that means this obviously this is frictional, d by dt of with respect to x is equal to 0. Why? Because this frictional torque is a function of x only. Yes or not? This is a function of x only. So if you differentiate this thing, d by dx into x minus x cube is equal to 0. So, from here x is equal to root under 1 by 3. This is your x value. Now, my dear, x is what? Small d by capital D you can write, and that is your 0.577. This is your d by d ratio. That means inner dia is equal to 0.577 times of outer dia, so that the torque transmitted. Now, if you draw the graph, there is a second concept is there. If you draw the graph between the frictional torque and d by d ratio. Clear? So, from this expression, my dear, if d by d ratio is 0, if d by d ratio is 0, torque is 0. You can say that, see, d by d, see, d by d is equal to 0. That means d by d is equal to 0. That means friction, there is no any friction torque. D by d is equal to 0. So, there is no any d by d is equal to 0. There is no any frictional torque. You can say that d by d. Okay. So, there is no any frictional torque. So, at this point, if it is 0, there is no any frictional torque. Now, if d by d is equal to 1, if d by d is equal to 1, again torque is 0. So, torque is 0 when d by d is 0 and when d by d is equal to 1. D by d is equal to 1, capital diameter is equal to bigger diameter. So, there is no any friction lining. This is smaller diameter, this is capital diameter. If smaller diameter is equal to capital diameter, so if smaller diameter is equal to capital dimension, there is no torque will transmit. Again it is 0. Yes or not? Again it is 0. D by d is equal to 0. So, again it is 0. So, at d by d is equal to 1, again torque is 0. Now, between d by d is approximately it is a 0.577. The torque is maximum. This is the condition for the maximum torque. So, torque is maximum. So, at this point, the torque is maximum corresponding to this, and initially it will increase, then it will decrease like that. It will increase, then it will decrease like that. And at this point, this torque is maximum. This torque is maximum. And what is this maximum torque? If you put d by d is equal to 0.777 in this equation, and if you solve this maximum torque is equal to 0.3849 pi mu d per power q. If you solve, this is your maximum torque. Clear? So, at this point there is a maximum torque, and if d by d is equal to 0 and d by d is equal to 1, the torque is 0. So, initially the torque will increase, reaches the maximum, then it will decrease. That is the characteristic. So, if d by d it will increase, so there is a certain value of d by d where the torque is maximum. So, we have to design according to this one. If you take below, and let's suppose you are taking d by d ratio here. Now, if you increase, the torque will increase. Once it reach 1.577, now if you again will increase d by d, so it will decrease. So, you cannot design the clutch in this regarding. You cannot design the clutch beyond 0.577 at uniform wear. Otherwise, torque will decrease. The clutch will not proper work. So, this is the one concept which is regarding this line. What is that? D by D ratio. So, this result, you have to remember this thing. At uniform wear, you can easily find for the uniform pressure also. Uniform pressure, so you can find uniform pressure also. Okay, that is the thing. Okay, now let's take the next problem. Let's take the next problem. This is the next problem. Yes, read this question first. A rotating bar made of steel of ultimate tensile strength is 630 is subjected to completely reverse bending stress. Subjected to completely reverse bending stress. The endurance limit of the bar, it is given 315 Newton per mm square. The fatigue strength of the bar, we have to find fatigue strength for the life of 90000 cycle. That means 9 cross 10 to the power 4 cycle corresponding. What is the fatigue strength? So this is basically the equation of SN curve. The question related to the SN curve. So I will give you again 1 minute time. Again 1 minute time. Just start. Time up. Okay. Done. So let's start this problem. Given what is given, my dear? Ultimate tensile strength, it is your 630 Newton per mm square. Endurance strength, it is your 315 Newton per mm square. Number of cycle N, it is given 940 cycles. Okay. Now, first we have to draw the SN curve. Why? Because SN curve is not given. And we know that SN curve is log curve. Okay. SN curve is your log curve. So, first we have to draw the SN curve. Strength versus number of cycle. SN curve. So, this is your log base 10 S. This is your log base 10 N. N is your number of cycle. Okay. So, here we know that this is your 0, 10 to the power 0, 0. Then it is your 3, 4, 5, 6, 7 like that. This is 10 to the power 3, 10 to the power 4, 10 to the power 5, 10 to the power 6, like that. After that, it is flat. Now, corresponding to n0 number of cycle, the strength, it is your material strength. That means here log base 10 Sm is called material strength. From here to 10 to the power 3 it will reduce, and this is corresponding, no, not a material, this is not a material strength, this is your ultimate, this is your SUT, this is 10 to the power 0, 10 to the power 3 corresponding log base 10 Sm. Now 10 to the power Sm to 10 to the power 6, this is a cycle corresponding to 10 to the power 6. Corresponding to 10 to the power 6, this is your log base 10 Se, endurance strength. After that, for a infinite number of cycle. Now they are saying that, so beta, this is your banding. So Sm is what? Sm is your material strength, corresponding to stress, that is stresses at 10 to the power 3 cycle is called material strength. Stresses at 10 to the power 3 cycle is called material strength. And we have note down for banding, this Sm is equal to 0.9 of SUT. So this value, it is your 567 Newton per mm square. Clear? Na? And this is your SU. So we have to find each term in the form of log. So log, we have start here. Okay, log base 10 number of cycle 900. How much it is? 9,000. How much it is? This is your 4.9542. So this is corresponding here. This is the point where the cycle is 4.9542. Corresponding to this cycle, what is the stress? That means log base 10 SF, we have to find it. This is our question. Now, log base 10 SE, endurance strength, it is given. So this value is 2.4983. Okay. Done. Log Sm, it is given. So log base 10 Sm, if you calculate, this is your 2.7536. So this is your 2.7536. This value, so there is a one triangle. So this is one, so here we have to find Sm. So there is a one triangle, this to this, and there is another triangle, this to this. So there are two triangles, this theta, and there is a total theta, this theta. So this triangle and this triangle, both angle theta is common. So this height divided by this height is equal to this height divided by this height. है ना? So we write like that here. This height is how much? Log base M Sm 2.7536. 2.7536, yes, 2.7536 divided by this one log SE, 2 point minus this, that means this distance by this distance. So this distance is 2.4753 and log is 2.4983, 2.4983 minus 2.4983 divided by base. Base is how much? This. So total is 6 minus 3. 6 minus 3. 2.498, 2.753, 6 minus 3. This is a bigger triangle, a smaller triangle. Smaller triangle, my dear. This is a smaller triangle, log base 10 SF divided by log base 10 SE. SE की value 2.49. SF divided by corresponding this value SE, and SE value it is given 2.4983. So this is your log base SF, log base SF, log base 10 SF minus endurance 2.4983, 2.4983 divided by higher 6 minus 4.952. 6 minus 4.9542. So if you solve, you can easily calculate SF here, and that is a 386.63 Newton per mm square, and it is approximately 387 Newton per. Clear? Clear? Just this is a minus. Just do this one. This triangle, this height divided by this is equal to this height divided by this. That is done. And remember, for that material strength is 0.91 of ultimate strength. This is from the design data book. From data book. My dear, in the gate, always this relation it is given, always. So don't worry about that. But you can always memorize this thing also, no problem. Okay? Why? Because this is very simple. Done? Now, we'll take the next problem. Yes, next one. Next problem. Read this question. A cantilever beam shown in figure, the beam it is showing, which is acting upon a fluctuating tip force F. So there is a F force is acting as a fluctuating, varying between 10.8 Newton and 25.2 Newton. The ultimate strength of the material it is 595 megapascal. Endurance strength of the material and yield strength are 299 megapascal and 270 megapascal respectively. The factor of safety by using Goodman theory. Okay, by using Goodman theory. So I will give again time for you just read and understand what the question पूछ रहा है. तो ये लीजिए. Done. Time's up. Okay, let's start this problem. So, given, what is given? Minimum force, and both are in same nature, 10.8 Newton. Maximum force, 25.2 Newton. Okay. From these two, we can easily calculate mean force, addition divided by 2, that is your 18 Newton. Variable force, subtraction by 2, that is your 7.2 Newton. Done. Similarly, this is our cross section, my dear. The cross section it is given. This is our cross section, the beam cross section it is given, and we know that this is our neutral axis. If this is a cross section is given, this is always neutral axis. This is our neutral axis. Once again, this is our neutral axis. Okay, this is our neutral axis, and from this neutral axis, this is your y at any point, and this dimension it is given 12.1 point. This dimension it is given 1.25 centimeter. This dimension it is given, and this dimension it is your 0.16 centimeter, and this is our cross section. So we can easily find what is the moment of inertia. dq is this one, 0.16 q into 1.25 divided by 12. So this is your 4 point, to calculate, this is your 4.27 cross 10 to the power minus 12 meter per power 4. Okay. Now, so it will see, this is a banding. This shaft is only banding. So this is a banding effect. So we have to calculate a banding moment. So what is the mean? So mean bending moment, distance from neutral axis divided by r. So what is the mean binding moment? Mean force, length into y divided by I. What is the force? It is given. Mean force we have find it 18 cross length. It is given how much? Length of the shaft 6 centimeter. So 6 cross y. Y is how much? Divided by 2. That means 0.08 into, see, 6 centimeter. So meter 10 to the power minus 2. 0.8 centimeter 10 to the power minus 2. So 10 to the power minus 4 here. Divided by I. 4.27 cross 10 to the minus 12. So this is what? This is what unit? This is your unit. That means this is your Newton per meter square. This is your Newton per meter square. That means Pascal. So generally we have to convert it in megapascal. So divided by 10 to the power 6. Automatically it is in megapascal. So if you calculate this value, it is your 202.34 megapascal. Clear? Now sigma variable, m variable into y divided by I, and m variable, f variable, L into y divided by I. What is f variable, my dear? 7.2. What is L? 6. What is I? 0.08. So this is your meter, centimeter, this is centimeter. Multiply 10 to the power minus 4 meter divided by I 4.27 cross 10 to the power minus 6. Obviously, we have to multiply 10 to the power 6. Minus 12 is there. This is minus 12, है ना? Minus 12. 10 to the power minus 12. Here 10 to the power minus 12. 10 to the power minus 12. So how much it is? This is your 80.937 megapascal. So this is your variable maximum. Now, according to Goodman, Goodman's relation, what is that? M by SUT sigma V by SE is equal to 1 by N. Mean 202.34, SUT 595, variable 80.937, endurance 229 is equal to 1 by N. If you solve the N value, it is 1.44. Simple problem. Clear na? This is clear? Done na? Okay. Done? So this is a problem. Now we have to take the next problem also. And the next problem, it is related to the brake. Yes, read this question. This is also simple question. A 400 mm radius brake drum contact a single shoes as shown below and sustained 2 to 5 Newton meter torque at 500 rpm. Okay. If coefficient of friction is 0.3, then the required force P to apply the brake for clockwise is. Okay. This is our NAT type question. Give your timer, please. I will give you time for complete the solution. डेढ़ मिनट. Okay, your time for डेढ़ मिनट. चलिए कंप्लीट सॉल्यूशन दीजिए इसका. Time up. Okay. So let's start. This drum is rotating at 500 RPM. Okay. So you have to draw the free body diagram or force diagram. So this is your drum. This is your drum beta. Now, and there is a lever. This is your lever. Okay. Let's suppose this is your lever. In which lever we have to apply the force here in this direction. P. Here it is a shoe, small shoes, brake. So here it is a shoes. Okay, this is your shoes. This is your shoes. Now, this brake is rotating in a clockwise manner. Okay. So on this one, there is a friction force F, and there is a normal reaction N. This F is mu into N. So on the shoes, this is your N, and in this direction, the friction force mu into N. Okay. Here it is your hinge. This dimension it is given. This dimension it is given, my dear. How much? 40. This dimension it is given 400, and this total it is your 900. It is like that, it is given. Okay. Now we know that braking torque TF is equal to what, beta? This force into this perpendicular distance R, है ना? So this braking force into R, and this braking force how much? Mu into N into R. This is your braking torque. Okay. In this question, braking torque it is given 225 Newton meter. 225 Newton meter. Mu it is given 0.3. N we don't have value. R it is given how much? 400. So this is 0.4. So from here we can easily find what is the normal reaction. So normal reaction is 1875 Newton. This is our normal reaction. This is our normal reaction. Now the second part, we take a summation of all the moment at a point. Let's suppose this point is O in anti-clockwise direction is positive, is equal to 0. This is the static equilibrium equation, one of the static equilibrium equation. There are 4 equations of static equilibrium. Summation of all the forces is equal to 0. Summation of all the forces in y direction is equal to 0. Summation of all the forces in z direction is 0. And summation of all the moment at any point is 0. So we have to write the moment balance. So this force into this distance, this force into this distance. So frictional force into distance is 40. Okay, this is also in this direction, plus P into 900. This is minus N into 400 is equal to 0. This is the equation, yes or not? Okay, we'll write what is the friction force? What is the friction force? Mu into N. So mu is 0.3. N, it is your 1875 into 40 plus P, we have to find it, into 900 is equal to N, we have 1875 into 400. From this relation, we can easily find P value. The P, it is your 808.3 Newton. Simple. Yes or not? This is very simple. Clear now? So this question is also clear, this thing. So this is your, then the required force P, the P required force is 808.3 Newton. Clear? This is also clear? Okay, now next. Yes, this is also very good problem. Just read this question, Vita. A cylindrical pressure vessel is joined by a lap. Okay, cylindrical pressure vessel is joined by a lap joint. Pressure inside is 10 megapascal. The inner diameter is 100 mm and thickness is 16 mm. Inner diameter is your 100 mm and thickness is your 16 mm. What are the number of rivet required per length? Number of rivet required per length if diameter of the rivet is 25 mm and yield shear stress of the rivet is 200 megapascal. Take factor of safety is 2. Okay. So again I will give you the timer and just start this problem. One minute. चलिए स्टार्ट कीजिए. Time up. This is very good question. Okay. What are the number of rivet required per unit length if the diameter of the rivet is 25 mm and yield shear stress is 200 megapascal? Take factor of safety is equal to 2. First, see this thing. As we know that this is a pressure vessels, cylindrical shape, maybe a spherical shape also, no problem. So particularly this is cylindrical shape. This is axis, z axis, x axis, and z axis, y axis, and x axis. This is length of the vessels, cylinder. So see, this direction is your longitudinal direction and this is your circumferential direction. This is clear. First direction is clear. This is your circumferential direction and this is your longitudinal direction. Okay. So if the stress will act in a longitudinal direction, the cylinder may be separated into two parts like that. Okay, this is a cylinder. So if the longitudinal stress will act both sides, the cylinder may be break up into two parts like that. So this is due to the longitudinal stress. And if this was cylindrical stress, if this was circumferential stress, so during the circumferential stress, cylinder will be fail along the axis. Circumferential stress, the cylinder fail along the axis. Longitudinal stress, the cylinder will fail along the circumference. That is a little bit thing. So, this is your, let's suppose this is your lap joint. It is saying that there is a pressure vessels in which there is a lap joint. So, in the lap joint, one plate over the another plate and there is a rivet. So, let's suppose this is your one plate, this is your one plate, there is another plate, this is your lap joint, and there is a riveting takes place, and there is a riveting, there is a rivet, my dear. Let's suppose this is your rivet. Let's suppose this is your rivet. Number of rivet is there. Number of rivet is there. Here we are applying the, in this one it is applying the force F. Now my dear, see this thing. How to relate this thing to this thing? Something it is given, the pressure, inside the pressure it is given 10 megapascal. Diameter of this rivet, diameter of what? Diameter of the rivet is equal to 25, and the inner diameter of the this vessels. So, this vessels have a diameter. This vessels have a diameter. This vessels have a diameter, and that diameter it is your 100 mm. This diameter it is your 100 mm, and the thickness, this thickness T. This T it is given 16 mm. This T it is given 16 mm, and this rivet dia it is given. This rivet dia. This dia it is given 25 mm. Okay, and we know that when there is a lap joint, the rivet will fail. There is a lap joint, rivet will fail during the shear. So, the shear strength value it is given, SYS it is given, is how much? This is given 200 megapascal. It is given 200 megapascal. And factor of safety it is given, you have to take 2. They are asking that number of rivet, N is equal to what? When length of this one is, that means, see, this is equal to per unit length, number of rivet required per unit length. Per unit length, that means per unit diameter, length of this one, this length. This length it is given unit, that means 1 meter. Okay, per unit length, that means 1 meter. Clear? This is given. Now, let's suppose circumferential, there is F1 force will apply. Longitudinal, there is F2 force is applied. Circumferential, there is F1 force is applied. Longitudinal, there is F2 force is applied. Okay. So, what is F1 then? F1 is a circumferential, and in the circumferential, force, it is what? Stress, that means pressure P into area. And what is the area? This area is what? This is circumference. This area is what? Diameter. 1 second. this circumferential na, circumferential force. So this is circumferential. Okay, F1 circumferential. Okay. 1 second. It is not there. Circumferential. This circumferential will develop. This circumferential will develop this type of cracks. This circumferential. So this area you have to take, and this area is what? D. This total length D into this length D into L. D into L. D into L. If you take this one D and L, L is this 1 meter, so here it is your 1000. If you solve, this is 1000 kilonewton. Now F2, it is your longitudinal. So during the longitudinal, it will fail in this direction, F2, longitudinal. So in the F2, pressure P into circumference pi by 4 d square, circumference pi by 4 d square. So if we calculate this thing, this is 78.54 kilonewton. Okay. Okay, done. So how much the total load will act on this joint? This total load F will act, and both are perpendicular. Both are perpendicular. So this will act, it is like that. Square root of F1 square plus F2 square. Yes or not? Both are perpendicular. Now what is F? What is F? F is your this force F. And how to calculate this F? F you have to calculate F. So F will act on this shear area, this one it will produce a shear. So the shear stress is equal to force upon area of this rivet. See, this is your rivet. So this is the area of cross section where the F will act. So let's suppose there are n number of rivet. Let n is equal to number of. So how many the shear area? N into AS. So what is the shear force? Total strength divided by pi by 4 d square area of one rivet. Let's suppose there is a n rivet, so multiply with n. And this is what? This is a level stress, na? This is a level stress. And what is the level stress? Failure strength. That means SYS divided by factor of safety multiply with pi by 4 d square into n is equal to a square root F1 square plus F2. Very important, I am telling you, this is very good problem. I am telling you, this is very good problem. So if you put this value F1, F2, SYS, N, all the thing it is given, N it is given, this is a factor of safety, okay? This is a factor of safety. And this is a number of rivet. So from this relation, if you find the value of N, find out number of rivet N, that is your 20.43 approximately 21. Clear na? So what is that beta? We are calculating the force. This is your force longitudinal circumferential, longitudinal circumferential, and this is your resultant force on the joint. This is due to the pressure, and due to the pressure there are two types of stress will develop in the cylinder, longitudinal and circumferential. So with the help of longitudinal and circumferential pressure it is given and corresponding area, we have to find F1 and F2. And both are perpendicular, so we have to take the resultant. That resultant is this one. Now equate this thing, simple. Now this force, it is on the plate and it will develop the shear. So this is your N into, what is that? Stress, force upon area. So this is force. So stress is called, this stress, this force is what? Stress is a force upon area. So instead of force, we have to write stress into area. And which is stress? Allowable stress. Which is stress? Allowable stress. And allowable stress is what? Failure stress. That means strength divided by factor of safety. Allowable by divided by strength divided by factor of safety. Clear? Okay. Now, so this is clear. Now we have to discuss with the next problem. Next. Yes, just read this question. If a taper, this is a taper roller, taper rolling bearing, this is tapering. See, this is taper roller. Yes or no? This is tapering. Taper roller. This is what tapering takes place. Okay. Now, in a taper roller bearing, if load is increased by 25%, we increase the load by 25%, then the life of bearing will be reduced by how much? देखो बेटा, in the taper rolling bearing, both axial and radial force will act, and there is a resultant force. There is a resultant force. And taper roller bearing withstand more radial load as compared to axial load. That means the ratio of radial load in the taper roller bearing, ratio of radial load divided by axial load is always greater than 1. Always greater than 1. So it is more suitable for withstand the radial direction of the load. More suitable with respect to the radial direction of load. So these are the radial load. Now, so we will start this problem. So as we know that tapered roller bearing can take both radial and axial load. And ratio of radial load divided by axial load is always greater than 1. Now, next. For this is roller bearing. For roller bearing, N is equal to 10 by 3. That means 0.3. Okay. So what is the life of the bearing, ball bearing? C by P power N. Okay. What is L? What is L, my dear? L is equal to fatigue life. Fatigue life in million of revolution. Million of revolution. What is P? P is your constant load applied. Yeah, load applied you can write. Load applied. Generally it is a radial. And C is equal to basic dynamic load. What is that? Basic dynamic load. So from here, C is what? P pe power L 1 by N. So this is P pe power L 0.3. This is equation number first. Now, if we increase the load by 25%, that means now my P dash is increase is equal to 1.25 with initial value. This is given. This is given. Okay. Then life will be, let's suppose L dash. L dash. So what is C dash? C dash is what? P L dash per power 1 by N. P dash L dash per power 1 by N. Yes or no? So P dash is what? 1.25 of P into L dash is L dash power 0.3. This is equation number 2. Take a ratio of these two. So C divided by C dash is equal to P pe power L 0.3 1.25 L dash per power 0.3. Yes or no? This P, this into P here, into P. P cancel, this C cancel. So L dash by L is equal to 1.25 per power 10 by 3. So L dash is equal to 0.4753 L. This is L dash. From here we have to solve. So percentage decrease is equal to L minus L dash divided by L into 100. Here 1 minus 0.4753 into 100. So this is your 52.47%. Clear? Simple. Clear? Simple value. You know this thing? This thing we can solve. No problem. Yeah, we can also take L directly proportional. L is your inversely proportional P per power N, and you can solve the problem. No problem at all. There is nothing, any problem. No any problem. Clear? Clear, my dear? Clear हुआ? Now next problem. Yes. This is also related to the bearing problem. So I think you can solve this problem. No problem. Eh? We can try to this this rivet problem. Okay. This rivet problem. This one. Okay. Read this question. A rectangular steel bar. This is a rectangular steel bar, my dear. Of length 500 mm. This length it is your 500 mm. Rectangular of length is 500 mm. 300, 100, 100, 500 mm. Width is also width, that means perpendicular to the board, 100 mm. 100 mm. Width is 100 mm. Okay, and thickness is 15 mm. This thickness is 15 mm. Cantilever to a 200 mm steel channel, 200 mm steel channel, 200 plus 100, 200 steel channel. Using 4 bolt at shown in figure, there is a 4 bolt. For external load is your 10 kilonewton applied at the tip of the steel bar. The resultant shear load on the bolt B, on this bolt, is round off. Resultant shear load. Resultant shear load. Okay, no problem. Just read this question. We'll discuss this thing. No problem. This is very simple. So these are symmetrical. These bolts are symmetrical. This is the method. So these are the bolt. Okay, let's suppose these are section. Okay, these are the bolt. One bolt, एक, दो, 3, 4. There is a 4 bolt is there. Okay. What is the CG? If you cross this one, this is your CG of this rivet. So this is your CG. This is your CG. This is your CG. Now here this force, see, this is the same plane. This plate, this upper plate and lower plate are same plane. So if the force is applied, if this plane and this plane are same, if the force will apply, the bolt is your twisting. On the bolt there is a torsional moment applied. This is your bolt, no? So this is your plate. Let's suppose this is your plate. Now if the plate on the plate there is a load applied, so plate want to rotate like that, so bolt will try to twist. So it will be twist. So there is a twisting. So what is the twisting moment? P load into eccentricity E. Okay. Now there is a direct load and shear load. So this, due to this force, there is a direct load and there is a shear load, a secondary load, primary load and secondary load. So shear load, direct shear load, it is downward. Let's suppose this is rivet to your 1, 2, 1, 2, 3, and this is 4. 4 rivet is there. So direct load, it is in this direction. Load is applied in this direction. So this is your direct load. You can take any direction. This is F1, direct load, direct shear stress, F2, F3, F4. And it will be twist in this direction. So there is a torsional perpendicular this length, F1 dash, F2 dash, perpendicular, F3 dash, perpendicular, F4 dash. It is clear? This force will applied perpendicular all this. Here L1 is equal to L2 is equal to L3 is equal to L4, and that is your, this is your L, and this dimension it is your 50, and this dimension it is your 50. Yes, it is given 50, and this dimension it is your 100. No, it is 100. 50 it is, 1 second. Yes, it is 50 also. This total is 100. This is also 50. This is also 50. See, 50. This triangle 50, 50. So this is 50 square plus 50 square. So this is 50 root 2. This is L. Now what is the eccentricity here? See, eccentricity is 300 plus 100. 300 plus 100. 400 is the eccentricity. Okay. Load is your 10 kilonewton. It is given. Now primary force same, symmetrical, F2, F3, F4. This divided by 10 F by 4, and that is your 2.5 kilonewton. Clear? Now secondary, F into E, F1 dash divided by L into L1 square plus, we know that, L2 square, L3 square, L4. This we know that. Okay. So F it is your 10, E it is your 400, F1 dash, L it is your 50 root 2. Yeah, you can say that F into L, and here it is your 4L square, 1L cancel. So this is your F dash. So this is your 4 into F dash into L L is how much? 50 root 2. So from here we can easily calculate F1 secondary force, F1 dash, and this is your 14.14 kilonewton. And these are same. These are all the same. These are all the same. Now my dear, which angle is, why? Because cos theta will increase, cos value will decrease, cos value will decrease, theta will increase, cos value will decrease, cos value will decrease. So which is the angle? So see my dear, which is the minimum angle? Minimum angle is a maximum force. Minimum angle is a maximum force. So maximum force, that means a critical bolt. So see, this angle and this angle is the minimum angle. Other one is the maximum. So either design your bolt 1 or either you design bolt 2. Both are the same. So theta is equal to how much? 90. This is total 90 minus this is 45. This is total is 90. Yes or no? Total is 90 and this is 45. So this is 45. So theta is what? Theta is what? 45 degree. So resultant force is what? Square root of primary force, secondary force plus 2 F1 dash cos theta. Now primary force 2.5 square, secondary force 14.14 square plus 2.5 into 14.14 cos 45. If you write this one, this is your 16 kilonewton. This is your resultant force. And they are asking, this is the answer of this question. They are asking that, see, the resultant shear load on the bolt B. On the bolt B. The bolt B. Clear? Clear beta? So this is the question related to the rivet. Now, जितना टाइम था बेटा 3 आवर में जितना कवर करना पड़ा उसमें करा, कुछ क्वेश्चंस और रह गए हैं, बट कोई नहीं, उसको हम ले लेंगे आगे. और जो नेक्स्ट सेशन होगा हमारा वो प्रोडक्शन का होगा. उसमें 2 डेज है. प्रोडक्शन विल टेक 2 डेज. ओके, 2 डेज प्रोडक्शन, 3 and 3 आवर विल कवर ऑल द टॉपिक. ओके, अप टू दैट, थैंक यू, बाय बाय. ओके, हाँ, उससे पहले कुछ अनाउंसमेंट्स देख लीजिए बेटा. कुछ अनाउंसमेंट है लास्ट में, एक बार फिर से मैं बता देता हूँ आपको. सी, if you join online classes, so there is some future 800 plus hour live classes with a live introduction, theory book and exercise book also there, in which 4000 plus question, and in the 4000 plus question there is L1, L2, L3 is there, and also there is a 33, this is not 34, 33 year of GATE question bank is there with video solution, and 12 personalized one-to-one mentorship. Personalized one-to-one mentorship, we can discuss one-to-one, one student, one faculty, one student, one faculty, and there is a 12 session is there in a year, and 130 plus online test with a video solution. That means what we are giving the online test, we have to provide also the video solution of this thing. Okay, and this is very important, this is the Telegram group free of cost, so you can join this Telegram group and you have a notification of these things, schedule of free Y2 lecture of all the PDF lecture. What is the information we are giving related to the YouTube? All the information will provide on the Telegram, and also there is a daily quiz which is very important for your update. So to join this one, we subscribe this channel beta. This channel will this link will subscribe automatically. You have to all the notification. Okay. Then thank you very much. Bye bye.